Next thing I want to talk about is what's called conceptual database design. And typically in conceptual database design, it's a high-level representation of a system. And we can show that with what's called ER, Entity Relation Modeling, or EER, Enhanced Entity Relation Modeling, which we'll talk about in a future video here, along with UML, the Unified Modeling Language, in terms of class diagrams. And with an entity relation model, entities typically refer to the objects or nouns within the system. And if we have parts of the entity, that's known as the attributes. And the relationship describes the behavior between two or more of these entities. So here's an example here. We've got an entity which is represented by a rectangle called faculty, another entity represented by a rectangle called student, and we would say faculty teaches student. And we use a diamond to show the relationship between those two entities. Now, in terms of faculty, the attributes might be social security number, rank, salary, for example. And the faculty or the entity would correspond to a database relational table, and the attributes are attributes in that particular table. Coming over to student, the student entity, we see attributes like social security number, the major, and last name. Notice that the keys, in this case social security number here, social security number there, are underlined, and so if we have attributes that are used as keys, we underline those. You'll also notice that we have M and N here. Typically, they show the number of instances that participate in the relation. So from a faculty perspective, he or she teaches many students, and from a student's perspective, he or she takes classes from many different faculties. And so this is known as a many-to-many or M-to-N relation. If we can have a one-to-one here, which is shown over here, or if we had a one-to-N or one-to-many, it describes a one-to-many, and if we have M-to-one, it's many-to-one. So there are four different forms of how they participate. As you recall before, we mentioned cardinality was referring to the number of rows. In this case, cardinality refers to the number of instances that participate. And there are four types of cardinality: one-to-one, one-to-many, many-to-one, and many-to-many. Now, what we want to do at some point is to take the ER diagram or the EER diagram or the UML diagram and actually map it to a set of database tables. And so, for example, if we took the ER diagram above, we might have one table, faculty, with social security number and rank, and another table called student with attributes, social security number, major, last name, and of course these are the keys there. Well, there are different ways of designing database tables, and some are better than others. One of the words we use is what's called data normalization or normalization. And when we talk about normalization, all it means is it describes how we structure the data within the database. So normalization has to do with structuring the data within the database. And I assume from undergraduate days you had seen different types of normalization, and they're giving numbers like this: first normal form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, fifth normal form, domain key normal form, and I believe there's even a sixth normal form. So we'll talk about the first several of these, and the ones I find used primarily in industry: third normal form, Boyce-Codd normal form, maybe fourth normal form. So through this semester, we'll just go up to fourth normal form. And we do this structuring, this normalization, because we want to eliminate redundant data, we want to better represent the real world data, and we want to have flexibility within terms of structuring the data. Well, the first level, and I'm going to give the undergraduate definition here, is what's called first normal form, or 1NF. And the definition is that all values are atomic. And so let's say we had a table, license number, state, driver, and student. And this is an example not in first normal form, because you can think of this as an Excel spreadsheet. We have one value in that box, one value in that box. But here we have three values. So this is not perceived as atomic. And to make that first normal form, or to make it atomic, we would create three separate rows, one for Bob, Carl, and Sue. And notice we have a lot of redundancy, a lot of replication of that information. So at this point, we've gone from not first normal form to first normal form. Second normal form, the undergraduate definition is it does not allow partial key dependencies. Okay, here's an example that violates second normal form. Suppose we have a library system and we keep track of books that are checked out. So we might have the card ID for the patron, the library ID, which library was checked out of, the book ISBN, which copy number, book title, and date checked out. Okay, now the problem is if we have card ID, library ID, ISBN, and copy number as part of the key, so it's a composite key for what that matters, book title only depends on the ISBN. So we would say this is a partial dependency because one attribute only depends on part of the key, in this case ISBN. So second normal form does not allow partial key dependencies. Third normal form does not allow what's called transitive key dependencies. And what that means is a non-key column is not dependent on another non-key column. So let's say we have a university database that has the following table called section, like course section. So a section is based on the course number, section number, term offered, the year offered, day and time the class is offered, and that's not a key because it's not underlined, the instructor social security number, and the instructor name. Now in this case, the instructor name depends on the instructor social security number. So this is a non-key dependent on another non-key, and that would be an example of a transitive key dependency. So this violates third normal form. And there's a video there called Introduction to Database Normalization. So that's first, second, and third form. We will be talking about voice cod normal form at some point and fourth normal form. But those are definitions I imagine you had seen in your undergraduate days. A couple other things. One is we have what's called entity integrity. And what that means is no attribute of primary key can be a null value. Another one is what's called referential integrity. And basically, if we have a foreign key matches with a candidate key or null, if the attribute B in relation F is a foreign key to RA relation A, the primary key, then there must be, basically, if you have a foreign key referring back to a primary key somewhere, that primary key cannot be null. Now, if that happens, let's say a student has a car and the car magically disappears. Now, in that case, what do we do with the foreign key in the student? You have to either set it to null or you delete that student. And sometimes you've got these dependencies where one foreign key depends on a primary key somewhere else, and that has a foreign key depends on a primary key somewhere else. And if the original one goes away, it's like a set of dominoes that fall down, and that's, a problem of what's called cascading delete, where one delete causes other deletes to occur in the system. Another one is to restrict primary keys delayed so there's no foreign key reference, or if the original primary key goes away, then set the foreign key to null. So that's the way we handle referential integrity. Enterprise constraints could be applied to the whole enterprise, such as a student cannot enroll in more than 100 credits, a bank balance cannot go below 0, just some examples there. We will be talking about relational algebra in a couple of weeks. And so some of the terms we'll see are select, project, join. Those are common. Others are semi-join, outer join. We'll go into more detail there. That might not be something you've seen before. Intersection, union, difference, and division. Okay. Finally, let me talk about physical database design. This is a very quick overview. Basically, in records, we can have fixed length or variable length records. We'll talk about the blocking of records, how to organize it. And then there's random access versus sequential access. There's different file structures, such as B trees, B plus trees. And after the midterm, we'll be talking about concurrency control, which includes ACID properties, which are atomicity, consistency, isolation, and durability. And transaction processing, we'll talk about locking and timestamps. Okay, and recovery, we'll be mentioning redo and undo operations. Finally, let me just talk about database lifecycle. Well, what we have is the definition of a database. Then there's conceptual design, which we'll be doing the first couple of weeks, which includes EER, UML design. Choosing a database, sometimes the choice has already been made for you and most likely be relational. Data model in terms of doing normalization. That's part of logical design. Doing some relational algebra. Then finally we do physical database design. So we have conceptual design, logical design, physical design in terms of keys, blocking, and setting up indices. Implementation means maybe setting up SQL, creating SQL tables, loading data, doing data conversion, any app conversion, testing, validating, operating, and maintenance. So those are the different phases. One more thing that you'll see is at the end of quite a few of these units, I've placed these inspirational thoughts and videos. I gave a commencement speech back 2010, and it is optional. Look at it. Hopefully the videos will inspire you to do better or be better people in society. And finally, there's review questions and exercise. Please look at that in your own time.